So what is object-oriented programming? Object-oriented programming is a, a way of thinking about code. It is a methodology, it's a type of programming that we haven't done yet in this class. It is considered to be sort of the more advanced standard in terms of how you create code because it sort of takes all of the things that we've talked about so far, including the idea of functions as black boxes, the idea that we can write code in a way that makes it reusable and portable and all those good things that make our lives easier as programmers. And so if you are in software development, at a basic bare minimum, you need to understand how object-oriented programming works in order to work with objects and classes that other people have built. But really, if you want to be a serious programmer, you kind of need to understand how to use object-oriented programming techniques to make your code better. Okay, so that's the reason for this, and that's the reason I'm giving it so much time in the class, is because it's both complicated and it's important. So that's why we're spending so much time with it. And by the way, after modules 14 and 15, we will be into the final modules of the class. The last four modules of the class are what I would call fun and interesting projects. They are in some ways advanced, but I think they're a lot more fun and a lot more interesting than some of the basic projects that we've been doing. So I'm looking forward to that part of the class. I think you'll enjoy it when we get there. We just have to get through this object-oriented stuff first. So why object-oriented programming? Well, object-oriented programming, why is it called that? Is based on the idea of something called classes. If you've taken other programming languages, you may have dealt with classes before, but a class, you should think of it like a blueprint. Okay, so if I have a blueprint, let's say for the creation of a car, the blueprint tells me important things about the car. It tells me what the car can do, it tells me how it's built, tells me things like size and shape and things like that. It is not the car itself. It is how we build the car, and it defines how the car is built. But the class is a model for something. It's a blueprint. Classes can define actions in terms of and there's an action in a class defined. It's called a method. It is defined in exactly the same way that we have been defining functions, but it belongs to that class. So a function is something that stands alone outside of a class. A method is something that belongs to the class. We've talked about methods before. We've talked about string methods. We've talked about array methods. We've talked about other methods in the class, and we've used them pretty extensively. And it's usually when we have something like string.ljust or something like that. Those are string methods. And string in that case is the object or the class that method belongs to. Classes can also define properties, which are values, also known as variables, but those variables belong to the class. Okay, that's the context for those. So when we create a class, or when we use a class, when we use that blueprint to create something, it can be called an instance of that class, and oftentimes it's called an object. So classes give us the ability to create instances or objects. And so that is why we call it object-oriented programming, because everything is defined in terms of objects and their properties and methods. So a class. When we want to define a class, let's say we want to create a class that represents a car. Okay, a car has a number of wheels. So that would be a property of the class. So if I have a class called CL car, it would have 4 wheels, and those number of wheels would be stored as the property int wheels. Again, just like a variable, but that variable belongs to the class. Now, when I want to create an instance of that class, I do it like this. It's just like assigning that to a variable. So that variable becomes an instance of CL car. And when I want to find out how many wheels that car has, I can do something like my car dot int wheels, and it will print the number of wheels that that car has. Now that car is born with 4 wheels. When I create this, because this is defined in the class, in the blueprint, my car automatically has 4 wheels to start with. So when I print that, it's going to give me 4. But I can directly access and change my car's wheels to 6. And that's what makes these things both elegant and complicated at the same time. So let's take a look. Here's my car class CL car, and I can say print F. Now my car has my car dot int wheels. Okay, because I've changed it to 6, and now I can print that just like before. I think I'm running the wrong thing here. Yep, I am. So let's run the right thing. If I want the right answer, that is sometimes helpful. So it prints 4, and then it changes that value to 6, and there you go. But here is what's powerful. You're thinking, why do we have a blueprint if I'm just going to turn around and then I have to create it again? Why have defined wheels at 4 if I'm just going to change it? Well, here's the interesting thing that we can do. I can say my other car equals CL car as well. So now I've got 2 cars. I've got 2 instances or 2 objects based on the same class. When they're created, they both have 4 wheels. But I can change the properties of each one. My other car has my other car int wheels. They both have that same property, but when I change that property to 6 for my car, my other car has its own set of things. And that's useful because now I can create copies of things that have similar abilities but different values. As we get more into this, my goal for you is to make this less esoteric and less abstract and show you how this is actually a useful ability.